Hello everyone. We will be today discussing the security technologies for the big data protection. So basically what are the technologies that are being used to protect the big data we will be discussing today. Now first of all, what is big data? Big data is basically, as the name suggests, the very massive and large amount of data. The data is so much large and vast in size that it can't be incorporated or being stored in the traditional storing systems or technologies. Like we have the relational database management systems. So that is my MariaDB or MySQL, Oracle. Now these databases are not capable of storing such large amount of data. Hence, we need to transfer towards the technologies that are capable of storing such large amount of data and process them as well. So we use Hadoop and various other technologies that are used to store the data. The Hadoop is very much capable of storing and processing the big data. Now, since the data is such large in size, it's again a very tedious task to maintain the authenticity of the data and also to protect it from not being tampered by the people who does not have access to it. So we will be discussing the technologies that are very important and are generally used to secure the big data. So the points that we'll be covering would be in the technology that we'll be discussing would be encryption, access control and identity management, data masking, data anonymization, audit trails and logging, firewalls and network segmentation, intrusion detection and prevention systems, data loss prevention, tokenization, sandboxing, blockchain for data integrity, security information and event management, and security data sharing and collaboration. So starting with encryption, we all know what do we mean by encryption in general terms means to convert the data into a form that can't be read by the common people. So basically we convert our data into a code, and that code can only be cracked through a decryption key. The data is being encrypted through encryption key and is decrypted by the decryption key. Now if we talk about like various cloud services as well, like AWS, they have their own key management services that are used to encrypt the data at rest and in transit as well. Data at rest means data when it is being stored in the management system, then also it is encrypted, and when it is being transferred from client to server or from various system to system, then also it is encrypted through the encryption key. Then it is being converted into a secure format, as I said, that it is being converted into a code into an unreadable format that can't be read without the decryption. So if you want, when you are transferring your data to a client, when you want the data to be read by the client, then you need to provide the decryption to the client to decrypt the data and read. Otherwise the person who is at the receiving end will also be not be able to read your data. So you need to provide decryption key. Then unauthorized access prevention, definitely crucial in safeguarding against unauthorized access and potential data breaches. So when you encrypt the data, the chances of the data being breached becomes very low, because since the person would not be able to understand what is being said, then the data is of no use of it. Okay, then the data is of no use to that person. So the unauthorized access can be prevented through encryption. So generally nowadays HTTPS protocol has been used, that is the hypertext transfer protocol. Secure people use HTTPS protocol so that they have so that they know that that website they're accessing is actually secured. So what do you mean by HTTPS? HTTPS means the data that is being transferred through HTTP is being secured and encrypted through SSL or TLS certifications. There are special TLS and SSL certificates that actually encrypt your data while it is being transferred from client to the server. However, it's a very different picture. We won't get into that, but this is all what encryption is about. Then we will come to second point, that is access control and identity management. It enhances security with RBAC and MFA. Firstly, what is the role based access control? Yeah, that's a very good thing. Like the best example I can give of this, definitely cloud, because for big data storage we use Hadoop, and as well as we use cloud as well, because cloud is one of the best methods to store your big data. So when we come to cloud, especially the AWS, it has the IAM policies and IAM roles as well. So the IAM policies and IAM roles basically list out all the people who are actually authorized to access that particular service's data, and the people who does not have that IAM roles or the IAM permissions, they will not be able to access those data. So role based access control. The role RABC assigns access right based on user roles, limiting data exposure and only what's necessary. Like for example, if I talk about developer, so we allow the developer to access only some part of your data of your database. We doesn't allow it to access the entire data, or we does not allow the developer to delete the table of your database. We don't allow it, but the administrator can do that. So basically, we've assigned the role, assigned the permissions according to their roles, that which role can provide which action. Like developer did not delete the table, but the administrator have the full access to entire database. He can do whatever he wish to do. He can even delete the table if he want. He can create the table as well. So it's up to him. Then come to multi-factor authentication. That's something very important and has been used very extensively by many websites. Like for example, if you even try to access the Google account in some other system, then also it uses the multi-factor authentication. That means just by knowing the password, you cannot access that account or data. Because it may be possible that somehow you just come to know the password of a person, and a person may just enter the password and get all your sensitive data. But no, through multi-factor authentication, that's not possible. Because even if you add the password, a special request will be going to be sent to your email address or to your mobile number, a OTP generally. And when you punch in that OTP, then only you will able to access the data, or you will be able to get into the database and access the data. So there is a special layer of authentication over the password as well. So it's a very good technology to secure your data. And like there are many kind of authenticators as well. Like there is Google Authy. There are several other authenticators that can authenticate, that provides you that special coded number, and after even providing the password, you need to add the punch in that number, and when you punch in that number, then only you will be able to access the data. This is the multi-factor authentication. So if you add this, your data would be extremely protected from any kind of unauthorized access. Then comes to data masking, obscuring sensitive information, securing data for non-production use. Obscure sensitive data, allowing non-production use without exposure. That means that your sensitive data would not be accessible to the person, or would not be seen by the person who does not have access to it. Okay. Facilitates analytics, enables analytics by using fictitious data instead of actual sensitive data. That means if even you are doing analytics, okay, suppose if you want to do analysis and you just want to analysis that what were the top 10 products that were sold in last month. So what you will do, you will query your data, but the it may be possible when you query your main production database, then it may do some kind of changes in a database. So you want that your actual database not being tampered or being used for this purpose, because your actual database is also being used to serve the request of the data. So it would hamper the performance of your database on your website. Your website may go down because it will be handling so much of request. You're doing analytics at the same time, and the client is also requesting its data from the database. So it will be a lot of performance issues as well. So and also so for both the situations, to protect your sensitive data also, and to not hamper your product performance of your database, it's better to create a clone of your database. That is what is known as data masking. The data you are actually using, this is a copy of the main data. You're not actually using the main data. So if you want to perform any kind of analytics, you want to do testing also, just don't do on the main production database. Use your clone, or it's like basically when you use AWS. So when we are using the AWS, when we use the relational databases, okay, like RDS or Aurora, then RDS or Aurora both have the facility to provide the read replicas. So any kind of testing that is to be done, or any kind of analytic has to be done, you can do on these read replicas or the AWS Aurora clone to perform any kind of it, so that your main database is not being tempered. And maintain this also maintains data privacy and security by preventing unauthorized access to origin. So your original data would not be touched, it would remain untempered. Okay, so the data masking is something very really important. Then come to data anonymization and protecting privacy, ensuring compliance in data utility. Definition of data. What is actually data anonymization? Data anonymization involves eliminating personally identifiable information, that is PII, from datasets, making individual identification impossible. That's something really important. It's very important that you eliminate any kind of personally identifiable information. For example, your age, your mobile number, your email addresses, your ATM pin, anything. Something that's very sensitive and that actually identifies you as a person, and your identity is being revealed through that information. You should eliminate that information from your data sets. So data anonymization is basically a technique through which all these personally identifiable information is being removed from the data sets so that the person can't be identified. Anonymization maintains data usefulness for analysis, enabling organization to derive insights without compromising privacy. Exactly. Once already all the PIIs are being removed and the data is clean and is very much ready for the test, for the being in the production, it's very important that your data is very much compliant and very much protected from any kind of unauthorized access. For this, the PII should be removed. Then this method enhances privacy by ensuring that sensitive information cannot be tracked back to individuals. Because using this personally identifiable information, the person can track you. Okay, and that's why, and can even steal your sensitive information, and hence to prevent that, it's very important to have the data anonymization so that the identity remains anonymous. Then next come to audit trails and logging. Again, very important thing. Essential for security and compliance. Audit trails, that mean whatever activity you are doing on your database, it should be tracked, it should be monitored, and it should be maintained. It should track all your audit tracks, all of your user interactions, on which date, at which time, what has been accessed by which user, so that there should be transparency in data access. Organizations leverage audit trails to meet regulatory requirements and bolster accountability. Logging facilitates the identification and investigation of suspicious activities, enhancing security measures. Definitely security will be enhanced because you know that which person did what kind of thing in the database. If anyone by mistake also deleted any kind of table, then you would come to that which person deleted that table. You can actually come to know. Okay, so it's very much important because, and you can hold that person accountable for what kind of thing he has done. So if any kind of configurational changes are made or any kind of interaction is being done, so you can actually identify if any kind of suspicious activity is going on in your company as well, because there are people who do steal your data to benefit themselves and to benefit your rivals. So by using these audit trails, you can, on it and this audit logs, you can actually identify if someone is even doing some unauthorized work or suspicious work on your data as well. Then network firewalls and network segmentations. Firewalls basically manages the inbound and outbound traffic, that who can actually access your data and who cannot access your data. It's basically a barrier for any kind of unauthorized access. Segregating network reduces exposure, minimizing potential attack surfaces. Basically, definitely it protects your data from being attacked. Like in AWS, there's various services that actually act as a firewall. There is WAF, that is the WAF is basically used to protect your data from any kind of like SQL injection, that is HTTPS attacks. So any kind of attack that has been made on your layer 7 on your application layer, that has been protected by the WAF, AWS WAF, WAF. And also from DDoS attacks protection, we used AWS Shield. So AWS Shield help you or protect you against your protect against the DDoS attacks. Then intrusion detection and prevention systems. This can be used to detect when any person is trying to intrude your system or trying to access your systems. Okay, so it monitors your threats. If any kind of threat has been like in AWS, there is a threat detection system that is known as if I'm not wrong, AWS Guard Duty. Yes, AWS Guard Duty is actually used to analyze all of your log data and analyze if there kind of any threat to your system or not. So to identify any kind of threat, we use Guard Duty. So similarly, there should be a system that monitors your thread, block any kind of potential threats, alert the administrators if any kind of such intrusion occurs. Proactive security approach, definitely, and integrity maintained. The technology plays a crucial role in maintaining the integrity of the big data systems, preventing unauthorized access. Okay. Then data loss. There should be a method to prevent any kind of data loss. Okay. Protecting sensitive information from unauthorized access. You should monitor your usage. There should be a control on the data, that how much amount of data can be transferred at a time. Okay, you should minimize data breaches and unauthorized access prevention. It's all about data loss protection. Then tokenization. What is tokenization? Tokenization substitutes sensitive data with non-sensitive tokens, ensuring security. So it actually substitutes your sensitive data with non-sensitive tokens, so that your data is secured from any kind of unauthorized access and your data is not been compromised. So it enables organizations to analyze data without exposing sensitive data. Enhances data security while maintaining operational functionality for the business. Then secure data sharing and collaboration. Techniques ensuring data protection during collaborative analysis. Enables collaborative data analysis without revealing sensitive information. Yes, so when we are doing collaborative work, when we are sharing our data, so we just make sure that the data is secure when it is being shared by third parties as well. Okay. Then security information and event management. Enhancing big data security with SEAM solution. Security information and event management solutions gather data from multiple security devices for comprehensive analysis. So it collects data from various devices and does analysis. Enhances the ability to respond to secure threats promptly. So if any kind of threat occurs, we can respond to it promptly. Provides immediate insight into security incidents, enabling quicker responses, and improves detection capabilities for threats in big data environments. Then blockchain is something I think very much used nowadays as well. Since it is decentralized and it is immutable. Okay, so it has been specially been logged in the hash code, and if you want to access any kind of data, so it's basically like a chain. So if you want to access suppose you want to access the third block, then you must know the hash code of previous two blocks as well, because the hash code of next block is saved in the previous block. So it's kind of a chain long. So the best security you can get is through blockchain, as it is immutable. The data that is stored in blockchain is permanent. It can't be tempered and can't be changed. It is unaltered, tempered through. Once the data has been entered, it cannot be modified or deleted. Okay, it is decentralized. It does not, when the major chances of data being breached is when data is centralized, when a single person had authority of all the data, that who can access it and who cannot access it. So then there is a chance of data being breached, or someone accesses your data, then there are chances. But in blockchain, it is decentralized. No one person have the access of the entire data of the blockchain. The data has been distributed across multiple locations in multiple areas of the entire world. So it's very difficult to attack data and get the data. So it's it's the best security method you can get. Then sandboxing. Sandboxing is like sandboxing basically refers to that it creates a testing environment for you where your data would actually be deployed, a system would actually be deployed. So it must allow organizations to safely evaluate an application without testing. So you do not want to compromise your main system, because you still you have a doubt that the system may get crash. So you just create a sandbox, a virtual an exam, or like a model kind of a environment where you will actually deploy your data and will check whether it's working properly or not. So while using sandboxing, you can isolate the threats. That's all. Thank you.